Hey, welcome back to another episode of Lucas is Busy. We're gonna finally get into the good stuff. I'm really excited. It's doing a lot of machine stuff, which is super fun, but my passion is cars. This is a tool. This is what it's about. Well, cars, engines and cars. It's been a lot of the machine because I've been prototyping parts for this giant turbocharger. So I just finished rebuilding it. If you're not following me on Instagram, you probably should, because I'm pretty story heavy with everything that I'm doing every day. To give you an idea of how big this thing really is this is the turbo that was powering this motor. Now this is the new one. Look at the size difference. It's already in the car, actually. I have two of these. This one I rebuilt with the tech that I built using this guy. The current tech is in that car. And I've had it up to 33 pounds of boost, but I was retarding the timing quite a bit, so the temps were pretty hot and you can feel the torque dropping off. But that was on 94 pump. So if we got some better fuel, we could turn it up even more, but the transmissions in the cars is notoriously weak, which is why this is not about turning up the boost as much as it is feeding the boost at really high RPMs. So the motor that's in that car is built with Manly pistons. Oh, those are the rods. Get this out of the way. So these are the pistons that are in there. They are Extreme Duty series with upgraded tool steel wrist pins, and the doesn't say it on here, but I went with the 22 millimeter wrist pin, which is for the 7-bolt motor. However, it's actually going in a 6-bolt motor because we all know 6-bolt motors are way better. Look at the packaging in these, they're so nice. These pistons also have the wrist pin. This is the wrist pin in here. It's the one that makes it do this. So the wrist pin that's in this one versus the wrist pins that are in these ones. This one is actually moved up, I don't even remember off the top of my head, 8 mils, 12 mils, something like that. So I end up with a longer rod. And then I got these rods, which is the Turbo Tough I-beam series. They also are a little bit longer, that 8 mil, 12 mil, whatever it is, to account for the wrist pin being moved up in the piston. And the reason you do that is it gives you a longer rod, so it changes as it's spinning around and coming up. It changes this angle, because this angle is what pushes into the piston wall, which is where the contact point is. So you want to minimize as much force as you can there. So one of the ways of doing that is by creating a longer rod at the same crank position. It's actually going to be a little bit less of an angle. What that does is allows you to spin up the motor a lot higher in RPMs and maintain a reasonable average piston speed. Average piston speed or max piston speed? It changes the piston speed, so it like slows it down, again, because of geometry and the way the rod angle is. And so the high RPMs is what we really want, because that giant turbo that I just showed you will feed this thing at 10,000 RPM in 35 pounds of boost. It's going to be a lot of fun. I haven't spooled that one up to 10,000 RPM yet because I'm still in the break-in period, and I'm really unhappy with how the piston wall was done by me last year. So last year, I used one of these. I don't even remember what it's called. What it is meant for, though, is hone stoning the inside of these cylinder walls. So what you do is you put it in a nice big 1/2-inch drill, which is not close to me, and you put this down and it spins, and the stones rub against the side, and these little felt wipers wipe the inside. And what that does is it creates a very nice concentric bore all the way down. It roughs up the walls, take down any high spots. Not really meant to get at the low spots though. I had read on some of the vintage engine forums that some guys had bored out the blocks doing it, and being cocky, I thought I would try it. I don't know if you see on the end here, this hone stone expands and it's got a fine adjust here, and it actually works really, really well for removing small amounts. 5 thou maybe. It's like, you know, you knock it down with the heavy stone and go lighter, 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 and just perfect for the piston rings to get a good bite. Now that I think about it, even 5 thou is too much for this. Just to bet you a couple thou, because I tried to bore this out, like I said, the 20 thou I needed, and I had a hell of a time. It took me forever. So not recommended to do this. I'm already getting a lot of oil in the exhaust, which probably means the rings are shot already, and a lot of blow by, which sucks because I only have about 800 kilometers on there. Lesson learned, don't be so cocky. So instead of using this guy, we are now going to use the boring bar as I should have to begin with. This little boring bar has a fine adjust on the end of it, which allows the head to move in and out as it spins around. Oh, well, the other way. So then what I'll do with this guy is I'll stick it down into the bore in the CNC machine, because, well, we didn't have a CNC machine last year, and bore this out the proper way. And then I'm gonna step through all the stones required to get that perfect cylinder wall that I am going for, that I'm going to get, because you need to be good at getting good cylinder walls if you're gonna be making 250 horsepower per cylinder, right? We need a good seal. So that's what it's about. So today marks the start of this whole series, I guess, or journey, or following my journey as I get that turbo with my tech in the car, bore this block out and rebuild. Oh no, not this block. This is my practice block. Yeah, not the way to do it. That's the stones are meant for finishing. Don't be an idiot like me and think you can just grab a big drill and do it, because it's not gonna last very long. The one that I have, the mains are exactly where they need to be, and the crank's exactly where it needs to be. Just everything is so tight on that block. It's even better than the one that I put in there. And that was a good block too. I don't know if I really want to talk about this today, but this is the blueprint for my block that's in there right now. And this is the blueprint for the head that's in there. Look at all these. It's pages and 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 pages of data. So the head that's coming off there is already built for 10,000 RPM as well. It's also built for 44 pounds of boost at 10,000 RPM. So it's a super duper capable head. It's been hand port matched, hand ported, and like, I don't have any flow numbers to back it up, but it's gonna be better than the crap ass casting that was in there before. Yeah, I really like the head. The head is super nice. I cut the valves, but I'm getting way ahead of myself. That's gonna come off. We're gonna probably talk about that. I'm gonna do practice boring tonight and talk about all the measuring equipment and how it's done, because when I jump into the actually building the motor, I'm probably gonna try and do it as fast as possible, which is why I'm doing the explanation up front. Because I measured the pistons that are in the motor that's gonna come out of the car, and they're in my blueprinting book. I know how much I need to bore the new motor. I'm gonna practice cut on this block. I'm gonna do 2 holes to make sure I really know what's going on. And then I'm gonna finish hone it as well, so that when I pull that block out and I pull the manly pistons out, I can take a measurement and see if they're bang on. I mean, at that point, I know there's nothing to worry about because we've done 2 practice holes. So doing the final bore on the good block shouldn't be an issue. The first thing that needs to happen to bore the block is I need to know how far these pistons are across. I use a micrometer to measure that. I'm not gonna get into how to read a vernier scale because you should be able to go look that up. But I just have little cheapo micrometers. I wish I could afford better ones, but they cost so damn much. So on this bigger micrometer, you take the calibration bar, you put it in between, and you torque it up and wiggle it around, because you gotta make sure it's all perfectly flat and in line, coaxially aligned with the anvils of the micrometer. I think that's what they're called, anvils. Yep, so we're perfect, still 0. So bang on 0 on this guy. Inside the Manly box, they give you a distance that you measured down from the top of the piston ring. Was it the piston ring or the wrist pin? It tells you on the piece of paper where to measure from, how far to measure down to, and then that's where you're supposed to take your micrometer measurement across. And then in that piece of paper, there's also the piston to wall clearance. So how you would do it is you just take the piston in there and make sure it's open enough first. And then you measure right across. But I have all that written down because I did that previous on this motor and I'm just repeating that. I'm just using better boring methods this time. So the measurement that I have in my blueprinting book is what we're gonna be boring today. So I like to set my bore dial gauge to the exact distance of the piston that I'm putting in there. And then anything over 0 is my piston to wall clearance. Now, last time, according to the book, I believe I did a piston to wall clearance of 3.5 thousandths. The Manly pistons that are in that motor are 3.376 inches across. So I know this is 3 inch, so I add 0.367, 67, 3 point, there we go, 3.3673. So now you take your bore gauge. I don't even know what the hell these are called. You put the right distance one of those in there. Oh man, it's still right on. Perfect. Wow, it's still there from last time. That's hilarious. Talk about repeatability. Look at that, it's bang on 0 still. And I like to do it so that it spins around to 0 and then has lots of room to go past. Because then when you put it in the bore, it's gonna squeeze it way around. And then as you open it up, it'll come back to 0 and then it'll go a little past 0. So now that we got our dial bore gauge set to our piston, well, the Manly pistons, we can check the bores of these. Well, I'm gonna do it this way because I can't read it. Like 2 thou over bore. Oh no, 22 thou over bore. Because this is set at 20 thou over right now. Oh yeah, and this is way under. That one's so way under and these ones are fine. Oh no. Under bore. So they're 18 thou under bore. Right? Man, I'm getting all confused now. Does this piston go in there? So how you do it is you stick it in there, you move it until you see the arrow peak and then come back, and where it peaks is where you kind of want to, that's where the measurement is. So this one is about half thou under bore, half thou undersize the piston, half thou about 1.2, and this one fits the piston with a piston to wall clearance of 4 thou. Now I don't know if that's what I want for piston to wall clearance. Now the boring bar that I got actually spins on with a right-handed thread, which means my right-handed boring bar, is that a right-handed or left-handed? I'm not even sure, but anyways, my boring bar is on the wrong side, but that's okay because right now is I'm gonna throw this on the lathe and try and bring it down to 3/4 to address the spinning. I'm gonna do a little weld here so that it never ever comes. I'll torque it on there really good and then I'll put some welds on there. So let's hop on the lathe. First thing I'm gonna do is bring her down, and I'm trying to like I don't want to go too far. Too far down because those like the crank webbing's in there, and it's critical I don't hit that because I'm pretty sure that's just gonna mess everything right up. So Oh, she moves pretty easy, actually, so. Just trying to be super careful as we come down here because I've never done this before, so, you know, I'm chicken shit, basically. I'm done, I still gotta get it all the way down there. I gotta tell you, that's a little nerve-wracking. Fuck, I can't even see all the way down there. If you don't have one of these mirrors, get one. Crazy useful. Oh, and I forgot it extends. Fuck me, I still can't see down there though. Fuck. Oh, that's totally crushing the light. Ah! Oh, little light. Whew. Well, she still works. It's lame though. Lucas, you dummy. You big dummy. I don't know if you can see it, but it's stepped to like this corner a little bit, and I'm not 100% sure why. I'm gonna get a dial indicator, and I'm gonna indicate that in a little better because I'm not sure why. There we go. Now she's shot in properly. That probe's close, but it's about a couple thou out, which is a big deal on a bore. Oh, you dirty Lucas. It has wrecked it because I forgot to put the offset in. Making a beautiful wall, but just a hair off still. Oh yeah, because I'm just barely biting into that, which means gotta come out a little bit, which is good. Okay, so that should be about a 4th thou cut. There's a complete engaged cut. How did that sound? Sounds about right. Sorry about that top ring, that was a little misalignment. Good though. Now the reverse pull. So I just finished the boring operation. So see that little line there, as I've mentioned, that's where the digital probe was just a hair out. I don't know if that was because I haven't indicated it in a while or what, but I decided to use the dial indicator and I went around and so I got it right on. What's really interesting though is down there. What's that? See that little guy? Yeah, you see this patch where it didn't quite hit it there. So this patch here where it didn't hit it, that's where the cylinder wall is out of round, and that's due to the stones. The stones don't cut it round, which is my whole problem. That's why I have so much blow by. That's why we're doing this, and you know, it just proves how crazy rigid and round I can make that cylinder bore. Like, ooh, it's nice. So in an effort to get rid of that ring in the bore, I did a lot of research, and there's a tool that I did not have, so I picked that up. I've seen it called a few different things, but it is a centering indicator. I don't know if this is a good brand, but it was a cheap brand. It's like 150 bucks, I think. It's also called a coaxial indicator. You put it into the spindle and then you spin it around, and the head at the bottom spins, but the dial stays facing the operator, me. So what that allows me to do then is it will move that little gauge. So the bottom of it, I'll put one of the little arm things in there, like one of these guys, probably the longest one, the biggest one. I like this one better for a first try. Not sure what that one's for yet. This is the first time I've ever done this, by the way. There's just a little flat spot there. No need to be crazy. So as it spins in the spindle, this will push on the wall, and then I'll move it around until it's directly on center. Pretty cool little tool. Oh my God, that's so long. So then you put this little arm in here, right? So that keeps the body straight. There, just like that. Woo! Pretty cool. That is really cool. Sorry, with all the new added lights in here, I noticed my ISO was at 100 and it was a little bright. I actually had to close the aperture a bit, which is good because now I actually have some control over the light. So there's a little nut up here. I think you just loosen it. Oh, okay, so I got the wrong one of these rods in there. There you go. Dip her down. right? I'm probably gonna have to swap lenses first, otherwise you're not gonna be able to see the face. Okay, so now I'm gonna turn it on. So that's a freshly cut bore, and I had to jig the machine, or re-zero the machine. I don't know, can you see that? You can't see that, I'll have to. I don't know, you can really ask for more. I probably could play with it more, but 2 to 4 tenths is good, I think, on a bore I just cut anyways, because you're really gonna see how shitty the bores get after you run them for a bit. And one other good bit of news though, is I wasn't sure if it was gonna reach to the bottom, but it's 6 inches to here, and I only need to go another 5.4 inches, which means I have lots of clearance to reach the bottom of the bore. And what that's gonna do is gonna tell me if it's ovaled in either direction, and also how concentric the bore is all the way down to the bottom, and how in line each bore is with every other. Oh, yeah, I don't know if I'll be able to tell that. We'll see. I'm excited to do some measuring though. So now that it's indicated on center, I moved the ball so it's just above the lip there. Just above that lip, because that ring is where the digital probe was just a hair off, where you could see it. Turns out it was not off by much. So if you look at the indicator face, you can just see it moving, and I'd say maybe 4/10,000ths of an inch of a lip on there, which is incredibly small, enough to see it though. So the way the digital probes come down and work is they break on an electrical contact, so there's some amount of movement required, and a CNC machine cannot stop instantaneously. And I was always kind of wondering, like, you know, if there's a little bit of error there depending on the velocity that you're moving when you trip the circuit, because the acceleration is a constant in the machine, so it takes a certain amount of distance to slow down. Turns out it's probably 4/10,000ths of an inch, and it looks like it's different in different directions, and that's possibly because it's like a 3-ball contact ball style probe. I don't know. This thing, however, because it is analog instead of digital, is going to give me a way better indication of where we are. So now let's go play with these bores. Okay, so now that we've got this all figured out, I'm going to move it over to this bore. Actually, I think I'm gonna go over no, I'm gonna go to this one. See how we started. See how the honing out bigger ended up. I expect super shitty. Let's check her out. I think I wanna put a little dab of the oil in there though. So she got a little lube. So we'll back her out. Take our new cool tool out. Now we'll come in and probe the bore. I'm gonna bring it down. Oh, no, I don't need to bring it down. We're trying to bring it in the center of the bore first. The far cylinder wall and this cylinder wall, it's out of alignment by what I would say is what, well, 1/1000th of an inch. And side to side, it looks pretty good though. It's like a few tenths off still in the X. So I just had to change the offsets there. Make sure we don't kill the... It's gotta be right near the bottom. Yep, that's at the bottom, perfect. Ouch. So at the very bottom of the bore, oh, that's interesting. Very interesting. It's about center, and about there, 3 inches down. It's about a 6-inch total stroke. So right there you can see that it is just slightly ovaled in the X. So it's just slightly ovaled this. So that's showing me that it's slightly ovaled this way by about 3 to 4 10,000ths of an inch, which I'd say is no big deal. So let's continue on our plunge. So we'll double check she's all the way down again. A couple clicks more. Okay, so now that we're at the bottom of the bore, crazily, it is like way out. That's the whole length of the bore. I don't know what more you could want, right? I mean, that's right at 0. Zero. Yeah, she got a little bit of an oval. I'd assume probably in the thrust direction because it's definitely shifted the one way. And it's more apparent as you go down. It's about halfway. Oh yeah, now you're seeing it. It's about 3/4 thou or 10 thou. This is nothing really. I think this block's been opened before though. That pretty much concludes her for the coaxial alignment check. I'm gonna set up the boring bar, and I'm gonna do one more bore, just skimming the surface again, just to see. All right. I indicated with this one, I cut it to about 2.5 thou piston to wall clearance, or a little under 1,000th of an inch to hone stone width. These ones are about 1 thou under the piston to wall clearance, so there'd be interference fit right now. I'm going to bring it out to just under 3 right now. We want it to be. So if I bring it in 2.5 thousandths, so that should now take 1,000th or a diameterally, so a 1/2 thou radially, which is not very much. So it'll probably make a pretty cool, interesting pattern. Now that we bored, we're gonna indicate in one last time, just to I'm gonna speed up the spindle and retract it. Man, it's gonna be so hard for you to see. Almost there. A few inches. That's hard to do. There you go, top. Okay, top of the bore now. As you can see, and I just think that's the speed at which I'm going. I don't know why, because if I slow it down, well, that's still there. I don't know, man. It's probably as good as she gets. I mean, I'm happy with that. I mean, the piston to wall's 3.5. I got little wobbles, nothing to worry about. Nothing at all. I mean, the bore is incredible. What would you expect for modern carbide tooling with the proper chip breaker on it and indicated in like that? Man, I am so happy with how everything came out. So now that I'm done this practice bore on the practice engine, it's time to get ready for that motor. So in the next video, we're finally gonna be getting into my car. I'm super excited to get into this because that's where the fun is. So what we're gonna do in the next video is be ripping out all the exhaust and turbocharger stuff and all the intake and everything and getting the motor out and getting the head pulled. And yeah, I'm not really sure where we'll go from there, but I do know we have no problem boring now that we got this great new tool. We need to see what condition the pistons are in that we're gonna be putting in that motor. They're Manly, Platinum Series, great pistons, heavy duty, ready to take 40 something pounds of boost that we're gonna try and throw at it. I need to get them out of the motor that's in there right now, so that's what's gonna be happening tomorrow. I should have that stainless steel manifold getting built and ready to go. Once that's done, I'm going to take the head and put some new seals in it. I'm pretty sure I damaged them last time putting them in. I had a hell of a time getting them on there, and I didn't know about that little straw trick, so I'm gonna do that this time. So we got some new seals for the valves, new gaskets for everything, new piston rings, new bearings. So we're gonna throw that all in the new block after we bore it with our newly acquired skill of boring engines. So yeah, it's gonna be a busy few days here. So make sure you subscribe on the way out because there's so much more to come. Thank you for watching, and I hope you have a good day.